Your brain is lying to you right now, not occasionally, not in edge cases, constantly, systematically, and with breathtaking precision. Every single moment you call the present, every heartbeat, every thought, every sensation you are experiencing as you read these words is already in the past by the time it registers in your conscious mind. You are not living in the now. You have never lived in the now. You are permanently displaced from reality by 80 milliseconds of biological lag, walking through a simulation that your own brain constructed to protect you from the terrifying truth about time. And here is the part that should genuinely disturb you. The laws of physics suggest the situation is far worse than a simple lag. According to the most rigorously tested equations in the history of science, the past has not disappeared and the future is not waiting to be built. They are simply different coordinates in a structure that already exists in its entirety. Your birth and your death occupy the same frozen block of space-time right now, at this very moment, separated not by time, but by geometry. You are not moving through your life. You are a static object in a four-dimensional crystal. And what you call consciousness is just a spotlight crawling across a warehouse full of statues that were never alive to begin with. Tonight, we are going to trace the full architecture of this trap. We are going to start inside your own skull and work outward until we reach the edge of everything. By the end, you will understand why your brain is stuck 80 milliseconds behind the universe, why your own body is being torn apart by time dilation, why cause and effect may actually run in reverse at the quantum level, why entropy means the universe is actively dismantling itself and using you to do it faster, and why mathematics suggests you might be doomed to repeat this exact life an infinite number of times without ever knowing it. This is not a philosophical thought experiment. Every single piece of this is grounded in real experiments, real measurements, and real equations. The horror is not invented. The horror is the data. Let's begin where everything begins, and where everything is already going wrong. Let's begin with the act of seeing. Right now, look at something nearby. Your hand, a wall, the surface you are sitting on. You are operating under a completely reasonable assumption that you are perceiving that object in real time. The universe is flooding through your eyes like light through a window, instant and unfiltered. It feels seamless. It feels like direct contact with reality. It is not. When light bounces off an object and enters your eye, it triggers a remarkably complicated chain of physical events. Photons collide with specialized cells in your retina, called photoreceptors. That collision triggers a chemical cascade. The chemical cascade converts itself into an electrical signal. The electrical signal travels along the optic nerve, passes through the thalamus, and finally reaches the visual cortex at the back of your skull, where it gets assembled into the image you actually perceive. That entire process takes time. Specifically, it takes approximately 80 milliseconds. 80 milliseconds sounds trivial. In the context of waiting for coffee or sitting in traffic, 80 milliseconds is essentially nothing. But in the physics of perception, 80 milliseconds is enormous. It is enough time for a bullet to travel 30 meters. It is enough time for a computer to execute millions of calculations. And it is an unbridgeable chasm between you and the present moment. Here is what that gap actually means for your experience of reality. By the time you consciously see your fingers move, the movement is already over. The event happened, completed, and entered the past before your awareness of it even began. The screen in front of you is not the screen as it is. It is the screen as it was 1/10 of a second ago. Every conversation you have is a conversation with the past version of the person sitting across from you. You are a permanent resident of the immediate past, watching a delayed broadcast of a world that has already moved on. Think of it this way. Imagine you are driving a car at night on an empty highway, but instead of looking through the windshield, you are forced to navigate using a video feed displayed on a tablet with a slight lag. You turn the wheel because you see a curve in the feed, but by the time you see it, the car has already entered the curve. You are steering by memory of where the road was, not by knowledge of where it is. That is your life. That is every life. You are the driver with the lagged feed, and your body is the car. The fact that you do not crash into walls every few seconds tells you something remarkable and deeply unsettling. Your brain knows it is slow. It has known this for the entire evolutionary history of the human species. And rather than accept the lag, it decided to cheat. Your visual cortex does not simply display the delayed image it receives. It runs a predictive model. It takes the information that arrived 80 milliseconds late, calculates the likely trajectory of every moving object in your field of view, extrapolates where those objects probably are right now, and renders that prediction as your conscious experience of reality. You are not seeing the world. You are seeing your brain's best guess about where the world was heading. This predictive engine is extraordinarily good. It is so good that under normal circumstances you never notice it. But it can be broken, and when it breaks, the machinery becomes visible. Consider the flash lag effect. In this perceptual illusion, a bright dot moves continuously across a dark background from one side to the other. At the exact moment the moving dot passes the center of the screen, a stationary flash of light appears directly beneath it. If your visual system were delivering raw, honest information about reality, you would see the moving dot and the flash perfectly aligned at the moment of the flash. They were geometrically in the same location at the same instant. But that is not what you see. Almost every person who takes this test perceives the moving dot as significantly ahead of the flash, as if it had already passed the center before the flash appeared. Your brain had already predicted where the dot would be, rendered that prediction as your visual reality, and when the flash fired, you saw the dot's predicted future position rather than its actual current position. Your brain is drawing a future that has not happened yet and calling it the present. Think carefully about the implications. You are not interacting with the world. You are interacting with a model of the world, constructed moments before the actual data arrived. For 99% of your daily experience, this model is accurate enough that reality and prediction feel identical. But they are not identical. You are walking through a continuous hallucination, and the moments where the hallucination breaks, where you drop something you thought you had caught, where you misjudge a step, where you reach for something that isn't quite where you expected it to be, those are the moments where reality and your brain's model of reality briefly diverged. This is the first layer of the trap. You are biologically sealed inside a slightly outdated version of reality, and the mechanism designed to compensate for that lag is itself a form of controlled hallucination. But there is a second layer that cuts deeper. If the conscious mind is already one step behind the eyes, what about the conscious mind's relationship to the body that contains it? Do you at least have control over your own actions, even if you cannot perceive the world in real time? In 1983, a neuroscientist named Benjamin Libet ran an experiment that has never stopped being disturbing. His setup was simple and devastating. He connected participants to an electroencephalography machine, which measures the electrical activity of the brain. He gave them a single instruction: move your finger whenever you feel like it. Not in response to a signal, not on a schedule. Pure spontaneous free will, uncoerced and self-generated. He also asked them to watch a clock face with a rapidly moving dot and note the exact moment they became consciously aware of the decision to move. The EEG revealed a specific pattern in the motor cortex, now called the readiness potential, a gradual buildup of electrical activity that precedes voluntary movement. The devastating finding was not the existence of this potential, but its timing. The readiness potential began building between 350 and 500 milliseconds before the subject reported being consciously aware of their intention to move. Half a second. In neurological terms, half a second is an eternity. Your brain had already initiated, planned, and begun executing the movement before your conscious mind received any notification that a movement was going to occur. By the time the thought "I want to move my finger" appeared in your awareness, the finger was already in motion. The decision was not made by you in any meaningful sense of the word you. It was made by electrochemical processes operating in the dark, below the level of awareness, and your consciousness was informed of the outcome, like a junior employee receiving a memo from a department they have no access to. The feeling of deciding, that sense of agency and authorship over your actions, is not the cause of what you do. It is the press release that comes after. The subconscious brain acts. The muscles respond. And then, almost a full second later, the conscious mind receives a narrative that frames those actions as choices freely made. You are not the architect of your life. You are the spokesperson. This conclusion sounds harsh, but it follows directly from the data. Libet himself spent years trying to find a way around it. He pointed out that subjects could veto a movement after becoming aware of the intention, suggesting consciousness might have a cancellation function even if it lacks an initiation function. But subsequent research has complicated even this escape. The veto itself appears in the brain's electrical activity before subjects report consciously deciding to cancel. It begins to look as though every layer of mental experience, the initial impulse, the sense of deciding, even the feeling of choosing not to act, all of them are post hoc narratives generated by a biological system that is simply very fast at making things feel intentional. We are trapped in a body that creates a fake present to navigate a world we cannot perceive in real time. We are trapped in a mind that creates a fake decision to explain actions we did not initiate. The biological machinery of time is built on two fundamental illusions stacked on top of each other. If the time inside your skull is this compromised, you might reasonably look outward for stability. Surely the universe outside your head runs on a consistent, objective clock. Surely there is a universal now, a single moment of existence shared by everything in the cosmos, an absolute standard against which all events can be measured. Isaac Newton believed exactly this. He called it absolute time. He conceived of time as a perfect, invisible container in which events occurred, a cosmic clock ticking at exactly the same rate everywhere in the universe. Unaffected by mass, unaffected by motion, unaffected by anything. In Newton's universe, a second on Earth was a second on Mars, was a second in the Andromeda galaxy. Time was the stage, the universe was the play. In 1905, Albert Einstein demolished that stage entirely. What Einstein discovered, and subsequently proved to extraordinary precision, is that time is not a container. Time is a landscape. And like any physical landscape, it can be warped, compressed, stretched, and distorted. The rate at which time passes is not fixed. It depends on two things: how fast you are moving and how deep you are in a gravitational field. Move faster, and time slows down relative to an observer at rest. The effect is not perceptual. It is not a trick of measurement. Physical clocks, atomic clocks, biological processes, all of them tick more slowly for a moving observer relative to a stationary one. The faster you move, the more dramatic the difference. Sit near a massive object, and time slows down. The stronger the gravitational field, the more warped the space-time around it, and the more slowly time passes for an observer embedded in that field. Near the surface of a neutron star, time crawls. Near the event horizon of a black hole, it approaches a standstill. An observer falling toward a black hole from outside would appear to freeze at the horizon, their clock slowing to zero relative to the distant observer watching them fall. These are not theoretical curiosities. They are measured facts, confirmed by experiment and exploited by technology. Every time you use GPS navigation, you are depending on Einstein's corrections to keep your location accurate. The satellites that make GPS work orbit at high altitude and high velocity. Both of those conditions affect their clocks. At altitude, they are in weaker gravity, and according to general relativity, their clocks run faster. At their orbital velocity, special relativity causes their clocks to run slower. The net combined effect is that GPS satellite clocks gain approximately 38 microseconds per day relative to clocks on the ground. 38 microseconds per day sounds like nothing, but light travels about 11 kilometers in 38 microseconds. If engineers did not continuously apply relativistic corrections to GPS calculations, the position error would accumulate at roughly 10 kilometers per day. Within weeks, your map application would be useless. The relativity of time is not an abstract philosophical position. It is the reason your phone can tell you where you are. What this means, at the level of the universe, is that there is no universal now. There is no moment of existence shared by all observers. Every object in the cosmos carries its own private clock, ticking at a rate determined by its velocity and its proximity to mass. Your clock and the clock of a fast-moving spacecraft are physically running at different rates. The difference is real, the divergence is measurable, and the two clocks can never be perfectly synchronized. You are not living in the same moment as anyone else, not precisely. The discrepancy at human speeds and human distances is so small it is unmeasurable without atomic clocks. But scale it up, extend the geometry, and the divergence becomes vast. This is where the relativity of time produces something genuinely frightening. It is a thought experiment proposed by the mathematician Roger Penrose, and it is called the Andromeda paradox. The numbers in it are real, the logic is airtight, and the conclusion, if you follow it to its end, suggests that the future is not open. Imagine two people, call them Alice and Bob, walking past each other on a street. They are moving in opposite directions at ordinary human walking speed, perhaps 5 kilometers per hour. The Andromeda galaxy is approximately 2.5 million light-years away. Because of their relative motion, Alice and Bob are cutting through the four-dimensional structure of spacetime at slightly different angles. The technical term for this is that their simultaneity planes are tilted relative to each other. On the scale of human distances, the effect is negligible. But Andromeda is 2.5 million light-years away. At that distance, even the tiny tilt from walking speed creates a massive divergence. In Bob's slice of now, let's say a council of beings in the Andromeda galaxy is still deliberating whether to dispatch a fleet of spacecraft toward Earth. The vote has not been taken. The outcome is undecided. In Bob's present moment, the future of that fleet is genuinely open. In Alice's slice of now, because she is moving toward Andromeda, her plane of simultaneity intersects the galaxy at a point days or weeks further along in Andromeda's timeline. In Alice's present, the vote is finished. The fleet has launched. Those ships are already on their way. Alice and Bob are passing each other close enough to nod. They share a single location in space. But Alice's present moment contains events that are in Bob's future. Now think about what that actually means. If Alice's present already contains the fleet launching, then that event is fixed. It has already happened somewhere in the structure of spacetime. If it is fixed for Alice, then it must always have been fixed. Bob is not witnessing an open future. He is watching a future that is already crystallized. He just lacks the information to see it. The Andromeda paradox implies that what we call the future is not a cloud of possibilities. It is a rigid landscape that already exists. We simply have not traveled to its coordinates yet. This implication is not just philosophical. The mathematics of special relativity demand it. If observers in relative motion can have different values of now, and if one observer's now already contains your future, then your future must exist as a physical fact at this very moment, somewhere in the structure of spacetime. The geometry of relativity allows no other interpretation. We are moving towards something that already exists. Every moment of your life, every decision, every accident, every conversation, every loss has already been laid down in the four-dimensional fabric of the universe. You are not writing your future. You are discovering it. But the strangeness does not stop at the scale of galaxies. It reaches inside your own body. You feel like a unified physical object. You feel like your head and your feet exist in the same moment, aging together at the same rate, inhabiting the same instant of time. This intuition is wrong. Your feet are closer to the center of the Earth than your head. Gravity decreases with altitude. The gravitational field at your feet is therefore slightly stronger than the gravitational field at your head. According to general relativity, stronger gravity means slower time. Your feet are literally aging more slowly than your head. In 2010, researchers at the National Institute of Standards and Technology measured this effect directly using optical atomic clocks, which are accurate to roughly 1 second in 300 million years. They placed one clock 33 centimeters, about 13 inches, higher than the other, and measured the difference in their tick rates. The higher clock ran faster. The gravitational time dilation across a distance of 13 inches was experimentally confirmed. You are not a single object in a single moment of time. You are a smeared event, a biological structure whose different parts are each experiencing a slightly different temporal rate. The gradient is tiny. In a human lifetime, the accumulated difference between head and feet amounts to a few nanoseconds, but the principle is absolute. There is no single time even within your own skin. If the universe does not share a common now, and if you are not even temporally unified within your own body, what holds the story together? What keeps events in order? What prevents your future from bleeding back into your past? The answer, in classical physics, is causality. The rule that causes must precede effects, and the mechanism that enforces it is the finite speed of light. Nothing travels faster than light. This is not merely a technological limitation. It is a structural feature of spacetime. And because light has a finite speed, the influence of any event can only propagate outward at a limited rate. This creates what physicists call a light cone around every event in spacetime. Inside the future light cone are all the events that could possibly be affected by the current event. Inside the past light cone are all the events that could have contributed to causing it. Everything outside both cones is causally disconnected. It is a region of spacetime that physicists call the elsewhere, and the elsewhere is vast. Most of the universe is in your elsewhere right now. There are stars exploding, civilizations rising and falling, astronomical events of staggering scale occurring at this moment in the Milky Way and beyond that are causally invisible to you. Their light has not reached you yet. Your signals cannot reach them. They do not exist in your physical world because existence, in any meaningful causal sense, requires the ability to send or receive information. You are sealed inside a bubble of causality. Everyone is. We are all locked in solitary confinement behind the walls of our own light cones, able to tap signals through the glass but never able to truly synchronize with anyone else's now. When you look at a friend sitting across the table from you, you are seeing them as they were a few nanoseconds ago, a tiny but real displacement. The person sitting across from you does not exist in your present. You are seeing their immediate past. Relativity ensures that every human relationship is a relationship with a ghost. If you find this unsettling but still tolerable, you are about to encounter a much deeper problem. We have destroyed the universal clock and replaced it with a chaotic mess of private time bubbles. But we still have causality. We still have the rule that the past is fixed and the future is uncertain. We still have the arrow of time pointing in one direction. Quantum mechanics is about to take that arrow and break it. To understand why the direction of time might not be as solid as it feels, start with a surprising fact about the laws of physics. Almost every fundamental equation in physics is time-symmetric. Newton's laws of motion work identically whether time runs forward or backward. Maxwell's equations for electromagnetism are time-symmetric. Schrödinger's equation for quantum mechanics, which governs the behavior of particles at the subatomic level, is time-symmetric. This means that if you filmed two billiard balls colliding and played the film in reverse, the reversed film would still obey the laws of physics perfectly. If you filmed the planets orbiting the sun and played it backward, the reversed orbits would still satisfy Einstein's equations of gravity. At the fundamental level, the universe has no preference for the future over the past. The laws that govern reality work equally well in both temporal directions. So why does time feel one-directional? Why does the coffee cup shatter when it falls, but never leap off the floor and reassemble itself into your hand? Why does ice melt in warm water, but warm water never spontaneously crystallize into ice? If the laws are symmetric, something else must be breaking the symmetry. That something, entropy, we will return to. But first, there is a more disturbing possibility hiding in the quantum equations. If time symmetry is genuine, not just approximate but mathematically exact, then there is no fundamental reason why effects cannot precede their causes. There is no law of physics that prevents the future from reaching backward through time and altering the past. And in 1984, an experiment demonstrated that something very much like this actually happens. The delayed choice quantum eraser is the most unsettling experiment ever performed in physics. To understand it, you first need the basic fact of the double-slit experiment, which is one of the foundational results of quantum mechanics. When individual particles, typically photons, are fired at a barrier with two narrow slits, they produce an interference pattern on a detector screen on the other side. The interference pattern is the same pattern produced by waves, not by particles. The photon appears to travel through both slits simultaneously, interfering with itself, as if it were spread out across space like a ripple on water. But when a detector is placed at the slits to observe which path the photon takes, the interference pattern disappears. The photon suddenly behaves like a particle. It goes through one slit or the other. The act of measurement collapses the quantum state. In the 1970s, physicist John Wheeler posed a question that sounds impossible. What if you allowed the photon to pass through the slits, waited until it was already in flight, already past the slits and heading toward the detector, and then decided in that moment whether to measure which path it took? The photon had already passed the barrier. The path was already chosen, or seemed to be. Could a decision made after the fact change what had already happened? When physicists built the apparatus to test this and ran the experiment, the answer was yes. When the experimenters chose to measure which slit the photon passed through, even after it had already passed, the photon was found to have behaved like a particle at the slits. When they chose to erase the which path information, destroying any record of which route the photon took, the interference pattern appeared on the detector. The photon had behaved like a wave at the slits. The photon's behavior at the slits, which occurred in the past, was determined by a choice made in the future. This is not a trick of measurement timing. The experimental protocol is specifically designed to eliminate that explanation. The choice of whether to preserve or erase the path information is made after the photon has already interacted with the slits. In terms of the sequence of events, the decision comes after the behavior it appears to influence. Physicists call this retrocausality. It is the possibility that causal influence can flow backward through time as well as forward. The word is carefully chosen to not claim that information can be transmitted to the past in a way that would allow paradoxes. But it does suggest that the timeline is not a one-way street. The future and the past are connected by a web of quantum correlations that our intuitions about causality fail to capture. Think about what this means for the solidity of the past. We instinctively treat the past as bedrock. Things that happened are done. They are fixed. They cannot be changed. But the quantum eraser suggests that the past, at the level of individual particles, is not fully determined until measurements are made in the future. History may be, to some degree, a probability distribution that collapses into a specific set of events only when the future asks about it. John Wheeler pushed this further in a principle he called the participatory universe. He argued that the past has no definite form until observers in the present reach backward through time and force it to take shape. By looking at the stars, by measuring the cosmic microwave background radiation, by digging up fossils and reading the age of rocks, we are not merely discovering a fixed history. We are collapsing a quantum cloud of past possibilities into the specific history that leads to us. The universe, in this view, does not have a settled past. It has a present that is continuously selecting its own history. This is vertiginous to contemplate. It means the ground beneath your feet is built moment by moment as you walk forward, and the ground behind you is dissolving back into potential as soon as you step off it. There is no solid foundation because the foundation is constructed retroactively by the same process it is meant to support. If the past can be changed from the future, and if consciousness plays a role in collapsing quantum states, then the question of what you are becomes very strange, very fast. Sir Roger Penrose, the Nobel Prize-winning physicist, and Stuart Hameroff, an anesthesiologist, proposed a theory called orchestrated objective reduction, or OR. They suggested that consciousness arises not from the chemical synapses between neurons, but from quantum processes occurring inside microtubules, which are tiny cylindrical protein structures inside neurons. These microtubules, they argued, are the right scale to sustain quantum coherence long enough to be computationally significant. If this theory is correct, your consciousness is a quantum phenomenon. It is subject to the same rules as the photon in the eraser experiment. It is subject to retrocausality. This raises a possibility that is either thrilling or terrifying depending on your disposition. If your brain is a quantum system subject to retrocausality, then your thoughts may not be solely the product of your past. They may be influenced, at least partially, by your future states. Decisions you experience as free and spontaneous may be shaped by a future that is reaching backward to guide them. You are not just moving toward your future. Your future may be pulling you toward itself. This is speculative. OR remains a minority position in neuroscience, and the question of whether biological systems can sustain quantum coherence under warm, wet brain conditions is genuinely unresolved. But the possibility cannot currently be ruled out. And the delayed choice quantum eraser is not speculative at all. It is a reproducible experimental result that physicists have confirmed in multiple independent laboratories. The arrow of time may be an illusion, the past may be mutable, and the future may already be reaching back through time to shape what we remember as our choices. Now we have dismantled three apparent certainties. The present has been replaced by a lagged simulation. The universal now has been replaced by a chaotic tangle of private time bubbles. The fixed past has been replaced by a quantum probability cloud that the future can rewrite. What we need now is a framework that makes sense of all of this. And when you try to build that framework, you end up in a place that is simultaneously the most intellectually satisfying and most existentially suffocating structure in all of physics. It is called the block universe. And it begins with a simple, logical observation. If Alice and Bob walking in opposite directions can have different slices of now, and if Alice's now already contains events that are in Bob's future, then those future events must have some kind of physical existence right now. They are real in Alice's present. They cannot be simultaneously real for Alice and non-existent for Bob. The only consistent resolution is that all moments of time exist simultaneously, and the difference between past and future is a matter of location rather than existence. The block universe is the view that all of spacetime, from the beginning to the end of the universe, exists as a single four-dimensional object. Every event that has ever occurred, every event that will ever occur, is already encoded in the structure of this object. The Big Bang is the jagged edge at one end. The heat death of the universe is the smooth, cold face at the other end. Your birth, your life, and your death are coordinates in between. Nothing in this structure is moving. Nothing is changing. The past has not disappeared, and the future has not arrived. They are simply different locations in a static four-dimensional geometry, the way New York and London are different locations in a three-dimensional geography. You cannot visit London from New York by waiting. You have to travel, and you cannot visit the future by moving through space. You have to move through time, but the destination exists. It is there. It is real. Think of the entire history of the universe as a film that has already been produced in full. Every frame is already printed on the celluloid. Every scene is fixed. Your consciousness is the projector, advancing through the frames one by one, generating the illusion of motion from what is actually a static sequence. The film strip sitting on the shelf is not playing. The frames are not animated, but the entire story is already there, from the opening shot to the final fade. In your particular scene, the hero may be wrestling with a decision. From inside the frame, the outcome feels genuinely uncertain. The hero feels the tension of not knowing, the weight of a choice not yet made. But outside the film strip, the next frame is already printed. The decision is already made. The outcome is already recorded. The uncertainty is a property of the character's knowledge, not a property of the universe. You are the character inside the frame. The universe is the film strip. In 1967, physicists John Wheeler and Bryce DeWitt attempted to do something that had never been done before. They tried to write the equation that describes the entire universe, combining quantum mechanics with general relativity into a single mathematical statement. The result is called the Wheeler-DeWitt equation. The Wheeler-DeWitt equation is elegant and compact. It describes the quantum state of the universe in its entirety. But when physicists examined it, they noticed something alarming. In almost every equation in physics, there is a variable for time. Things evolve over time. States change as time passes. But in the Wheeler-DeWitt equation, time cancels out completely. The variable disappears. The equation says the universe has no time. As a whole, the cosmos is a static zero-energy state. It does not evolve. It does not change. There is no before and no after at the level of the whole system. What we experience as time, the flow, the progression, the sensation of moving from one moment to the next, is a local feature of our limited perspective inside the system. From outside the system, viewed in its entirety, there is no time at all. Nothing has ever happened. Nothing ever will. The universe simply is. The Wheeler-DeWitt equation is not fringe physics. It is the mainstream attempt by serious theoretical physicists to unify quantum mechanics and gravity. Its implications have been debated for decades and not dismissed. The absence of time in the fundamental equation of the universe is not a bug to be fixed. It may be the central fact about reality. If the block universe is real, if the future already exists as a fixed structure in four-dimensional spacetime, then we have to face a consequence that strikes at the most intimate part of human experience. The future is already decided. What you will do tomorrow, who you will become, what you will choose and suffer and create and lose is already written in the geometry of spacetime. In the block universe, free will, as we normally understand it, cannot exist. This requires careful examination, because the initial response is usually resistance. You feel like you are choosing as you read this. You could stop, you could skim ahead, you could set this down and walk away. The sensation of agency is overwhelming. But consider what that sensation actually consists of. You feel uncertain about the future. You feel that multiple options are available. You feel that your deliberation will influence the outcome. But in the block universe, the future coordinate in spacetime already contains a specific version of you doing a specific thing. That version is physically real, etched in geometry, just as your current state is etched in geometry. You will not choose from a set of genuine options. You will navigate toward a destination that already exists. Think of a roller coaster. Strapped in the car, you feel the adrenaline. You lean into the curves. You grip the safety bar. You experience the ride as dynamic and in motion. But the track is fixed. It was designed and welded into place before you bought the ticket. The sensation of velocity and uncertainty is real. The experience of being in a moving system is real. But the outcome of every turn was determined by engineers who never knew your name. This does not mean deliberation is meaningless. In the block universe, your deliberation is part of the structure too. The thinking, the weighing of options, the sense of uncertainty, those are all etched into the block, along with the outcome they lead to. The deliberation is real. The experience is real. What is illusory is the idea that the outcome could have been different. You are not a puppet. The strings are not being pulled by an external controller, but you are a character in a story that is already finished. The feeling of writing as you go is part of the story. The story was never being written as you go. At this point, we have built a structure of considerable philosophical grimness. Biology has sealed you in the recent past. Relativity has locked you in a private time bubble. Quantum mechanics has dissolved the solidity of history. And the block universe has frozen the entire trajectory of your existence into a static four-dimensional object. But physics has a fifth layer. It is the layer that tells you where the block universe is going and why it can never go anywhere else. It is called entropy. The second law of thermodynamics states that in any closed system, entropy, which is a measure of disorder or randomness, always increases over time. Energy spreads out. Heat flows from hot objects to cold ones, and never in reverse. Organized structures decay into disorganized ones. The second law is absolute. It has never been observed to fail, and it governs every physical process in the universe, including you. The reason entropy always increases is purely statistical. Consider a deck of 52 cards. When the deck is brand new, the cards are in perfect order, suits arranged sequentially, ranks in order from ace to king. This is a state of extremely low entropy. There is essentially only one way to be in this configuration. Now, shuffle the deck. The shuffled state has enormously higher entropy. There are approximately 8, followed by 67 zeros, different ways for 52 cards to be arranged. The overwhelming majority of those arrangements look disordered. When you shuffle, you are almost certain to land in one of the countless disordered states rather than the one ordered state. This is why entropy increases. Disorder has astronomically more ways of being realized than order. When a system evolves randomly, it inevitably moves toward the states that have the most ways of being instantiated, which are the disordered states. Apply this to the physical universe, and you get the arrow of time. The past feels different from the future, because the past is the direction of order, and the future is the direction of disorder. We remember the past but not the future, not because of any mysterious property of consciousness, but because our memory records are preserved by the lower entropy conditions of the past. Entropy is what gives time its direction, and time's direction is toward dissolution. Your body is a temporary fortress of order in a universe that is systematically destroying all fortresses. You maintain that order by eating, sleeping, breathing, and metabolizing. But here is the cruel joke of thermodynamics. In order to maintain the local order inside your body, you must generate more disorder outside it. You consume low-entropy energy, food, and sunlight, and excrete high-entropy waste, heat, and metabolic byproducts. You are not fighting entropy. You are accelerating it. Every heartbeat, every thought, every step you take requires the consumption of ordered energy and its conversion into disordered waste. Life does not reduce entropy in the universe. Life is one of the most efficient mechanisms the universe has for increasing entropy. Some theorists have proposed that the reason life evolved at all is that living systems are extraordinarily good at dissipating energy gradients quickly, speeding up the universe's march toward thermal equilibrium. We think we are building civilization. We may be the universe's fastest route to its own heat death. And the heat death is where everything ends up. As entropy increases and energy spreads out, stars will exhaust their nuclear fuel and go dark. Over inconceivably long timescales, even black holes will evaporate through Hawking radiation. Eventually, the universe will reach a state of maximum entropy. Every gradient will be gone. Temperature will be uniform everywhere, just a vanishingly small fraction above absolute zero. Nothing will ever happen again, because every event requires an energy difference to drive it, and there will be no energy differences anywhere. This is the end of time. Not a catastrophic end, but a quiet one. A vast frozen silence stretching through infinite empty space, in which not a single particle will ever move in a directed way again. But here is where physics delivers one final piece of information that makes the heat death look almost comforting by comparison, because there is something potentially worse than the universe going quiet. There is the universe never going quiet at all. Consider the mathematician Henri Poincaré, who in 1890 proved a theorem in statistical mechanics that has haunted physics ever since. The Poincare recurrence theorem states that any finite physical system with finite energy and finite volume will, given enough time, return to a state arbitrarily close to its initial state. The key word is finite. The universe appears to contain a finite number of particles, approximately 10 to the power of 80, organized by a finite set of physical laws, operating within a finite observable volume. If the timeline is infinite, or even just extremely long compared to the recurrence time, then this finite inventory of particles must eventually revisit configurations it has already occupied. The recurrence time for our universe is staggering. It is a number so large that if you tried to write it out with a zero on every atom in the observable universe, you would run out of atoms before finishing the exponent. But it is finite, and if time goes on long enough, the number becomes reachable. What does recurrence mean for you? It means that the specific arrangement of atoms that constitutes your brain, your memories, your personality, your subjective experience, this exact configuration, will be assembled again by the random shuffling of particles. This does not require any supernatural mechanism. It requires only time and probability. Given enough of both, the cosmic lottery will eventually produce your winning ticket again. The atoms that make up the neurons of your brain will, somewhere in the future of the universe, fall into the exact same configuration they are in right now. And when they do, whoever inhabits that configuration will have your memories, your fears, your loves, your sense of being a continuous self. They will wake up and continue your thought without any knowledge of the trillion years that passed between. You are not a unique event. You are a recurring pattern in an infinite manuscript. The universe writes you, erases you with death, and then, because it has nothing else to do with eternity, writes you again. Friedrich Nietzsche anticipated this in the 19th century with his concept of eternal recurrence, long before the physics that supports it was developed. He called it the heaviest burden. He asked you to imagine a demon who visits you at night and tells you that you must live this exact life again and again, after that, infinitely, with nothing new, nothing changed. Every detail repeated with perfect fidelity. Every moment of joy, every instant of humiliation, every physical pain, every boring afternoon in traffic, every heartbreak and every triumph, reproduced identically in a loop without end. The physical version of this nightmare is worse than Nietzsche imagined because it lacks even the continuity he described. In his scenario, you might at least know you are repeating. In the physics of recurrence, each cycle begins with the memory reset to zero. The you that wakes up in the next recurrence will not remember having lived this life before. You cannot accumulate wisdom across cycles. You cannot grow, you cannot escape. The repetition is not experienced as repetition because each instance begins at the same point of ignorance as the last. You are not just trapped in a loop. You are trapped in a loop that conceals itself by resetting your memory of it at the beginning of every iteration. And statistical mechanics adds a final cruelty. For every precise recurrence that recreates you exactly as you are now, there will be vastly more near recurrences that recreate you imprecisely. Health is a state of high order. There are relatively few ways to be healthy. There are millions of ways to be broken. The probability that the universe reconstructs a version of you in pain vastly exceeds the probability that it reconstructs a version of you in comfort. In the infinite shuffle, the typical outcome is suffering. The moments of genuine well-being are the statistical outliers. We may be living in one of those outliers right now. We may be the rare, comfortable version, surrounded by countless, slightly worse versions of ourselves that we can never know about. Now sit with the full picture for a moment. You are biologically sealed 80 milliseconds behind the present, interacting with a predictive hallucination rather than the world itself. Your sense of deciding is a narrative constructed after the fact by an unconscious system that initiates all your actions without consulting you. There is no universal now, only a chaotic tangle of private time bubbles drifting apart from each other at every moment. The past is not a solid foundation, but a quantum probability cloud that the future can disturb. The entire trajectory of your life is already encoded in a four-dimensional block of frozen spacetime that cannot change and does not move. Entropy is systematically dismantling every structure you build, and your very existence is one of the mechanisms it uses. And the end of all this is either the eternal silence of heat death or the eternal recurrence of the same experience, lived again and again in a cycle that cannot be remembered, cannot be escaped, and cannot be improved. That is the architecture of the trap. But here is what is strange about architecture. Sometimes a structure that looks like a prison from the inside looks like something else entirely from the outside. Look again at the biological lag. Why does your brain take 80 milliseconds to process vision? Because the alternative would be catastrophic. If your conscious mind received the raw, unfiltered, unprocessed stream of sensory data from a universe that moves at the speed of light and operates on quantum probability, the result would be incoherent noise. The lag is a filter. It is a shock absorber. It is the price of a brain that can function at all in a universe that is fundamentally too fast and too strange to perceive directly. Look at the speed of light limit. It seems like a constraint, a wall that prevents you from ever reaching the stars in a human lifetime, a barrier that isolates you behind the walls of your light cone. But without that limit, causality collapses. In a universe without a maximum signal speed, effects could precede causes. Your decisions could arrive at their destinations before you made them. The entire coherent story of a universe that can be understood by minds like yours would dissolve into paradox. The light speed limit does not imprison you. It makes a universe in which stories are possible. Look at the block universe. It seems to turn your life into a finished object, a static thing that cannot be changed. But without the block, the past would vanish. Every moment would be truly gone the instant it ended. Your memories would be not just fading records, but references to something that literally no longer existed. The block preserves everything. Every moment of beauty, every connection, every instant of genuine experience is permanently encoded in the geometry of spacetime. Nothing is lost. Nothing disappears. The past is not dead. It is crystallized. And look at entropy. It seems like a death sentence applied to everything you care about. But without entropy, there would be no arrow of time. Without the arrow of time, there would be no causality, no growth, no change, no experience of any kind. The very fact that you can feel anything, that you can think anything, that you can want anything, depends on the existence of energy gradients that entropy is in the process of leveling. Entropy is not just destroying the world. It is the engine that makes experience possible in the first place. The trap is real. The walls are real. But if you look at the whole structure, you begin to see that the walls were not built to confine you. They were built to make you possible. Without the biological lag, you could not navigate a world that moves too fast for raw perception. Without the speed of light limit, you could not live in a universe with coherent causality. Without the block universe, the past would not exist. Without entropy, the present would not exist. Every constraint that limits you is also the condition that permits you. The trap is a life support system. This does not dissolve the strangeness of your situation. You are still a biological machine, permanently displaced from the present, interacting with hallucinations, carrying a frozen copy of your death in the same four-dimensional structure as your living self, condemned by entropy to eventual dissolution, and condemned by statistical mechanics to eventual recurrence. None of that changes. But the question of what to do with this information is now genuinely open. The philosopher who confronted a version of this most directly was Nietzsche, and he did not propose despair. He proposed amor fati, which means love of fate. Not the passive acceptance of whatever happens, but the active embracing of it, the transformation of necessity into choice. If the universe is what it is and cannot be otherwise, the question becomes, how do you inhabit it? In a universe with no inherent meaning, meaning becomes a thing you create rather than discover. The absence of a cosmic script means you are not failing to fulfill a purpose. It means you are free to assign purpose wherever you choose. A walk with a friend, an afternoon spent building something, a moment of genuine understanding shared with another person. These are not inferior substitutes for some higher cosmic significance. In a universe that has no cosmic significance, they are the only significance there is. And because time is finite, because entropy is real, because the window of conscious experience in which you can create and feel and connect is genuinely limited, each of these moments has a value that immortality would destroy. Scarcity creates value. This is as true of moments as it is of anything else. If you will live forever, no single afternoon matters, because there will always be another one. It is precisely because the deck is running down, because the entropy is rising, because the heat death is coming, and the recurrence will not preserve your memory of this version of yourself, that this version of yourself, right now, in this moment, matters. The musicians on the Titanic understood this without knowing the physics. The ship was going down, the math was clear, the iceberg was already behind them, and the water was already rising, and they played. Not because the music would stop the water, not because it would save lives, not because it served any practical purpose that the laws of thermodynamics would recognize, but because the act of creating beauty in the face of certain ending is itself the point. It is the only answer the human species has ever found to the silence of the cosmos, and it is a good answer. Every time you create, connect, love, or build understanding, you are creating local order in a universe that prefers disorder. You are increasing complexity in a system driving toward homogeneity. You are a momentary flame in a universe of increasing cold. And that is remarkable. Not because the flame lasts. It does not last, but because it was lit at all. What scientists are still working to understand is the nature of time's emergence. The Wheeler-DeWitt equation suggests that time does not exist at the fundamental level of the universe, but we clearly experience something that functions like time. How does a timeless fundamental reality give rise to the time-bound experience of creatures like us? This is called the problem of time, and it is one of the deepest unresolved questions in theoretical physics. Some physicists, like Carlo Rovelli, argue that time emerges from the entanglement between quantum systems. When one system interacts with another, the correlations between them create a directionality that we experience as temporal order. Time, in this view, is a relational property. It exists between things, not in things. It is not a background against which events occur. It is something that emerges from the relationships between physical systems. Others, working in the framework of loop quantum gravity, suggest that space-time itself breaks down at extremely small scales, the Planck scale, where the conventional geometry of general relativity gives way to a discrete network of quantum connections. At this level, neither space nor time exists in any conventional sense. What we call the fabric of space-time is an emergent, coarse-grained description of something fundamentally different. The question of whether time is fundamental or emergent, absolute or relative, real or constructed, remains genuinely open. Physicists are working on it. Experiments at future particle colliders and gravitational wave observatories may help constrain the options. The Event Horizon Telescope, which produced the first direct image of a black hole's shadow, is helping physicists test the behavior of space-time at extreme conditions near event horizons. These are not abstract philosophical exercises. They are empirical investigations into the nature of reality, and their conclusions will matter. What is clear is that the intuitive picture of time, the steady forward flow of moments from past to future, is not an accurate description of what physics tells us about the universe. Time is not what it seems. The present is not accessible. The past is not settled. The future is not open. The universe is not a story being written. It is, at minimum, a story that is already complete, and we are characters who cannot read ahead. Knowing this does not simplify your situation. It complicates it in ways that have no clean resolution. The physics of time does not tell you how to live, but it does give you something valuable. It gives you clarity about the nature of the ground you are standing on. The ground is strange. The ground is more uncertain, more fluid, and more deeply weird than any of your instincts suggest, but it holds. The laws of physics, bizarre and counterintuitive as they are consistent. They are measurable. They produce a universe in which minds like yours can exist and ask questions like these. That is not nothing. In a universe of cold gas and silent rock, the fact that matter has organized itself into systems capable of understanding the nature of time is remarkable. It is a statistical improbability of staggering magnitude. Roger Penrose calculated that the probability of the universe beginning in the specific low entropy configuration required to produce something like us is 10 to the power of 10 to the power of 123. That number is so large that writing it out, placing one digit on every particle in the observable universe, would require more particles than the observable universe contains. We are a rounding error. We are a fluctuation. We are a glitch in the second law of thermodynamics that has somehow persisted long enough to become aware of itself. But a galaxy cannot love. A galaxy cannot grieve. A galaxy cannot look at the equations that describe its own structure and feel the vertigo of understanding. One human brain processing this information, this moment of genuine comprehension, is doing something that has never happened anywhere in the observable universe for the first 14 billion years of its existence. The block universe says the moment is already frozen. Entropy says it will not last. Recurrence says it will return without your knowledge of having been here. But right now, the spotlight is on this part of the warehouse. The frame is lit. The needle is on this groove. Whatever the physics turns out to be, this is the coordinate where you are, and it has never existed before, and it will never exist again in precisely this configuration. Do not waste it waiting for a better one. The better one is not coming. This one is it. This is the only moment where the block permits you to act, where the needle is touching the vinyl, where the consciousness is illuminating the statues. Later is a coordinate you have not reached yet. Earlier is a coordinate you cannot return to. There is only here. So whatever it is you have been waiting to do, whatever conversation you have been delaying, whatever work you have been deferring to a version of yourself that will have more time, or more certainty, or more courage, the physics is clear. That version does not exist. The time is now, because now is the only coordinate that has ever been available to anyone. The universe is strange. Time is broken. Entropy is winning. The past is frozen. The future is decided. And the present is a controlled hallucination your brain constructs to protect you from the speed of reality. And yet here you are, a momentary fluctuation of improbable order, thinking about all of this and finding that you care. That is the most remarkable fact of everything we have covered tonight. Not the block universe, not retrocausality, not the Poincare recurrence. The most remarkable fact is that the universe has produced something that looks at itself and finds it worth understanding. Keep going. The clock is running. If you found this worth your time, sharing it costs you nothing, and it keeps the conversation alive. The questions we have been asking tonight about time, consciousness, the nature of reality, they are the questions that define what it means to be a mind in a physical universe. They deserve to keep being asked. The trap is real, but you are conscious inside it. And consciousness, however brief, however improbable, however deeply strange its relationship to time turns out to be, is the only thing in the known universe that has ever noticed the trap at all. That is not small. That is everything. There is a final thread worth pulling, one that runs through everything we have covered and connects it in an unexpected way. It concerns the relationship between information and time. In 2016, physicist Charles Bennett and his colleagues at IBM explored a question that seems almost philosophical. What is the connection between the act of erasing information and the physical arrow of time? The answer they found goes to the heart of why entropy increases and why time flows in the direction it does. When you delete a file from your computer, you are not just removing a pattern of ones and zeros, you are converting organized, low-entropy information into heat. The erasure of information always generates thermal energy. This is called Landauer's principle, and it has been experimentally confirmed to extraordinary precision. Every time information is destroyed, the entropy of the surrounding environment increases. Now think about what happens when you forget something, when a memory fades in your brain, when a thought dissolves, when an experience is not encoded and passes without being preserved. Information is erased. Entropy increases. The arrow of time takes another step forward. Your mind is not just experiencing time, it is physically producing it by participating in the erasure of information. This connects to something even stranger. Physics defines information very precisely. Information is the opposite of entropy. When a system is highly ordered, it contains large amounts of information. When it is disordered, it contains little. The universe started with an enormous amount of information in its highly ordered initial state. Entropy's increase means information is being systematically destroyed. The universe is forgetting itself. The arrow of time is the direction in which the universe loses memory of what it was. You are not swimming against this current. You are part of it. Every time you think and forget, every time your neurons fire and the heat they generate raises the temperature of your skull by a tiny fraction, every time the information in your experience is converted to metabolic waste, you are participating in the universe's fundamental process of self-forgetting. But here is the strange flip side. Before the information is erased, while it is still organized, while the memory is fresh and the pattern is intact, it has physical substance. Information is not abstract. It has weight and energy and physical location. The physicist John Wheeler coined the phrase "it from bit," suggesting that physical reality itself, the three-dimensional world of mass and force and space, might emerge from an underlying fabric of information. In this view, the universe is not made of matter. It is made of data. Matter is what information looks like when you are inside the computation. If this is correct, then what you are is not primarily a collection of atoms. You are a pattern of information encoded in atoms. Your identity, your continuity, your experience of being a self persisting through time is the persistence of that information pattern. When entropy destroys the pattern, you cease to exist. When the Poincare recurrence accidentally reassembles the same pattern, the same information, you exist again. What dies in entropy is not you, the atoms. Atoms are indestructible within ordinary physical processes. What dies is you, the pattern. What the recurrence resurrects is not your atoms, but your information. The you that returns after a trillion years of recurrence is not made of the same matter you are made of now. It is made of whatever atoms happen to be available, but it contains the same information. And if you are your information, then it is you. This is the materialist version of an ancient religious intuition, that what matters about a person is not the physical substance of their body, but the pattern that substance temporarily instantiates. The body decays. The pattern potentially persists, or recurs, or echoes in some form through the structure of the universe. There is no mysticism in this observation. It follows directly from the physics of information, probability, and recurrence, but it changes the emotional tenor of the picture somewhat. You are not primarily a collection of atoms. You are a pattern, a specific, highly improbable, extraordinarily complex pattern of information that the universe has stumbled into instantiating in this particular corner of spacetime. The atoms that make you up are churning through you constantly. The cells of your body replace themselves continuously. The matter changes. The pattern continues. And the pattern, unlike the matter, is what the universe will eventually reassemble. Physics is also still wrestling with one of the deepest unresolved questions in the field. Why did the universe start in such a low entropy state? The second law tells us entropy increases. It does not tell us why it started low. Every physical process we understand obeys time symmetry at the fundamental level. There is no law that prevents the universe from having started in a high entropy state and evolved toward lower entropy. The existence of the low entropy beginning is not explained by the standard model of particle physics or by general relativity. Some cosmologists, including Sean Carroll and Jennifer Chen, have proposed that our universe is a fluctuation within a much larger multiverse that is itself in a state of maximum entropy. In a sufficiently large and old multiverse, even maximum entropy regions will occasionally fluctuate into low entropy pockets by pure statistical chance. Our Big Bang in this view is one such fluctuation, a momentary bubble of order in an eternal sea of chaos. We are not just improbable within our universe. We are improbable within the larger context that produced our universe. Others have argued for cyclic cosmologies, in which the universe repeatedly collapses and rebounds in a Big Crunch and Big Bang cycle, with each cycle beginning in a relatively low entropy state. In some versions of these models, the entropy is genuinely reset between cycles. In others, it accumulates, and each cycle is slightly higher entropy than the one before, trending inexorably toward the maximum entropy state over a series of cosmic cycles. None of these proposals is confirmed. The question of the universe's initial conditions is still open, and it may be the deepest open question in physics. Because until we know why entropy started low, we do not fully understand why time has a direction. We do not fully understand what the arrow of time actually is. There is also a question about quantum gravity that directly affects the block universe picture. Einstein's general relativity treats spacetime as a smooth, continuous geometric structure. Quantum mechanics treats matter and energy as discrete and probabilistic. When you try to combine these two theories into a single unified framework, something breaks. In loop quantum gravity, one of the leading approaches to unification, spacetime itself becomes discrete at the Planck scale. Instead of a smooth four-dimensional continuum, reality at the smallest scales is a network of discrete quantum chunks of geometry, each of Planck length, approximately 1.6 times 10 to the power of -35 meters across. Below this scale, the concept of space and time breaks down entirely. In this picture, the block universe as a smooth geometric object may be an approximation. At the deepest level, what we call time may be a large-scale statistical pattern that emerges from the behavior of a vast number of discrete quantum geometric elements, the way temperature emerges from the average behavior of individual molecules. You cannot ask about the temperature of a single molecule. Similarly, you may not be able to ask about the time of a single quantum of spacetime. If time emerges from the statistics of quantum geometry, then the question of whether the block universe is truly static, whether the future is truly fixed, becomes much more complicated. It might be that the block-like structure is real only at the level of the large-scale smooth approximation, and that at the underlying quantum level there is genuine indeterminism, engine openness, genuine unfixed futures. This would be enormously consequential for the question of free will. If the future is not fixed at the level of quantum geometry, if the equations of quantum gravity leave genuine room for uncertainty at the most fundamental level of the universe, then the roller coaster track is not fully welded. Some of the turns may be genuinely undetermined. Some of your choices may be, in a physically meaningful sense, real choices. The experiments being planned and built right now at facilities like the Laser Interferometer Space Antenna, which will observe gravitational waves from merging supermassive black holes, and future successor missions to the Event Horizon Telescope, may provide data that helps constrain these quantum gravity theories. The next decade of physics is likely to produce information that will change our picture of time in ways we cannot yet predict. What remains stable, what seems unlikely to change regardless of which theory of quantum gravity proves correct, is that time as you experience it is not what it is. The smooth, objective, universal flow from past to future is an approximation, useful at human scales, but deeply wrong about the underlying nature of reality. Einstein proved this. Quantum mechanics reinforced it. The Wheeler-DeWitt equation pushed it to an extreme, and every refined measurement of the cosmos since then has confirmed that the universe is stranger and more temporally bizarre than common sense allows. The strangeness is not going away. It is deepening as the instruments get better and the theories get more precise. Time, which seems like the most fundamental feature of experience, the inescapable backdrop against which everything happens, may turn out to be the universe's deepest illusion. Not an illusion in the sense of being unreal, but an illusion in the sense that its apparent nature, its smooth flow, its universal objectivity, its clear direction from past to future may be properties that emerge from something far weirder that lies beneath. Whatever lies beneath, you are inside it right now. The spotlight is moving. The needle is playing this groove. The four-dimensional amber has you caught in this particular configuration for this particular flickering instant of the cosmic timescale. Notice it. It will not come again in quite this form. The trap of time is real, but you are conscious inside it. And whatever time ultimately is, however strange its nature turns out to be, the fact that it has produced something capable of asking what it is the most remarkable fact of the matter. The clock is still running. Keep going. There is one more dimension to this problem that we have not yet fully explored, and it may be the most personal one. We have talked about the physics of time, the neuroscience of perception, the thermodynamics of entropy. But there is a question embedded in all of this that is not a physics question at all. It is a question about what you are when you are stripped of the comfortable assumptions about time that ordinary experience provides. Your sense of self, your experience of being a continuous person moving through time, depends entirely on memory. You know you are the same person who woke up this morning because you remember waking up. You know you are the same person who was a child because you have memories of childhood. The thread of identity is woven from memory. Without memory, there is no continuity. There is no self that persists. There is only a series of momentary experiences with no connection between them. But what is memory? In the physics we have been discussing, memory is information. It is a pattern encoded in the specific connectivity of your neurons, the strength of synaptic connections, the distribution of protein molecules across roughly 100 billion cells. That pattern is physical. It has weight, location, and energy. It exists in space and time as a concrete physical structure, and it is constantly decaying. Every night, some synaptic connections weaken. Every year, some neurons die and are not replaced. The physical substrate of your memory is slowly degrading under the pressure of entropy. The memories you form today are already more fragile than they will feel. The pattern that constitutes you is already slightly different from what it was a year ago. There is a question in philosophy of personal identity called the ship of Theseus. The ship was brought back to Athens after a long voyage. Over time, every plank, every sail, every nail that composed it was replaced as parts deteriorated. After a long enough period, none of the original material remained. Was it still the same ship? Philosophers have argued about this for 2,000 years. You are the ship of Theseus. The atoms in your body are replaced continuously. The cells replace themselves over years. Even your neurons, long assumed to be permanent, turn out to replace their molecular components constantly. The physical substance that makes up the pattern of you is not the same substance that made up the pattern of you a decade ago. What persists is the pattern, but the pattern itself is changing gradually, updated by every experience, every memory formed, every synaptic connection modified. At what point does the pattern change enough that it is no longer you? There is no clear answer. There is no threshold, no moment of discontinuity where the old you ends and a new you begins. Identity is not a crisp category. It is a smear, a gradual transition, a pattern that changes slowly enough that continuity is a useful approximation even though it is not literally true. And in sleep, the approximation gets even thinner. Every night, your conscious experience stops. There is a period of several hours during which the processing that generates your experience of being someone is suspended. The pattern of activity that constitutes your waking consciousness is interrupted. When you wake, a new instance of that consciousness begins. Is it the same consciousness as the one that fell asleep? Is there a meaningful sense in which you survived the night? Or did the person who fell asleep cease to exist, and a new person with access to their memories wake in their place? This sounds like a question without a practical answer, but the physics we have been discussing makes it sharper. If consciousness is a process rather than a thing, if it is something the brain does rather than something the brain contains, then interrupting the process is genuinely interrupting the consciousness. The pattern continues. The information is preserved. but the experience itself stops and starts. You have died and been resurrected several thousand times already. Each morning is a resurrection. Each night is a small extinction. The you that wakes tomorrow will have access to your memories. It will have the same neural architecture, the same personality, the same relationships and fears and hopes. But whether it will be you in any deep sense, whether the consciousness is continuous or newly instantiated each morning, is a question that neither neuroscience nor physics can currently answer. This should change how you think about the Poincaré recurrence. The version of you that recurs after a trillion years is not more discontinuous from you than the version that wakes up tomorrow morning. Both involve a gap in conscious experience. Both involve the reconstruction of the pattern from stored information. If tomorrow's you is you, the argument for the recurrence being you becomes stronger. If tomorrow's you is a new person with your memories, the continuity of identity throughout a lifetime is already broken every single night. These are not idle philosophical puzzles. They are questions about the nature of what you are, and the answers matter for how seriously you take any of the threats and consolations we have been discussing. If identity is the pattern and not the substrate, then entropy is not destroying you. It is destroying the physical medium that currently instantiates you. The pattern, stored in the block universe, is permanent. The pattern, capable of recurring by Poincaré recurrence, is not finally lost. But if identity requires not just the pattern but the continuous thread of experience that connects moments of consciousness, then every night you die. And in that case, the terror of entropy is fully warranted. Because when the pattern is finally disrupted irreversibly, when the neurons stop firing and the heat of your body dissipates into the surrounding environment and the information that constituted you spreads into the ambient noise of the cosmos, that thread is cut. Whether it can be picked up again by recurrence is the question, and the answer depends on whether the thread of identity requires continuity of experience or only the continuity of the pattern. Physics cannot resolve this for you. What physics can tell you is that the pattern is real, that information is physical, that entropy is systematically destroying the information that constitutes you, and that statistical mechanics gives the pattern a non-zero probability of being reconstructed. What you do with those facts is up to a system of values and priorities that physics has nothing to say about. That is where you come in, not the biological machine processing sensory data 80 milliseconds behind reality. Not the unconscious system generating actions before your conscious mind is notified. But whatever it is that reads these words, weighs their implications, and decides what they mean for the way you intend to live. The physics describes the walls. You decide how to inhabit the space inside them. These questions will not be resolved quickly. The problem of time in quantum gravity is one of the hardest open problems in theoretical physics. The question of how consciousness relates to physical processes, including temporal ones, is arguably the hardest problem in all of science. The question of whether identity persists through interruptions in conscious experience is a problem that may never have a definitive empirical answer. But the investigation continues. Physicists are building better instruments and refining better theories. Neuroscientists are developing more precise maps of the structures and processes that give rise to conscious experience. Philosophers are clarifying the conceptual landscape, identifying which questions are genuinely open and which turn out to dissolve when examined precisely. We are, in aggregate, getting better at understanding what we are and what the universe is that contains us. The rate of progress is slow relative to the timescales the physics involves, but it is real. Every decade, the picture gets clearer. Every new experiment refines the constraints. The strangeness does not go away, but it becomes more precisely understood strangeness. And there is value in precise understanding even of things you cannot change. The trap of time is real, but you know about it now. You understand the mechanisms. You can see the walls clearly. That is not nothing. That is the only thing that separates a conscious being from a rock. The rock is also subject to entropy, also embedded in the block universe, also constrained by the speed of light, also eventually subject to Poincaré recurrence. But the rock does not know this. You do. And in a universe that may be timeless at its foundation, the fact that something inside it has become capable of asking what time is remains one of the most extraordinary events that the equations have ever produced. Let's go even deeper into one of the threads we have been pulling on: the relationship between consciousness and time measurement. Because there is something profoundly strange about the way the brain measures duration that reveals yet another layer of the trap. Your sense of how long something lasts is not a clock, it is a narrative. The brain has no single timing mechanism analogous to the clock crystal in a computer. Instead, it infers the passage of time from multiple signals simultaneously, the number of events that have occurred, the amount of information processed, the state of the body's internal chemistry, the content of working memory. Duration is a construction, not a measurement. This is why time passes at different rates depending on what you are doing. When you are deeply engaged in a task, when your attention is fully occupied by something interesting or demanding, the brain processes large amounts of information in a dense stream. Events succeed each other rapidly. The interval between now and then is densely populated with experience. When you look back, that period feels long because it contained a great deal. When you are bored, when you are waiting, when the environment offers little new information to process, the brain has little material to work with. The internal stream of processed events is sparse. An hour contains relatively little, and it drags accordingly. But here is the reversal. In retrospect, the opposite is true. A vacation filled with novel experiences, new places, new people, new sensations feels short in the moment because each present instant is absorbed in immediate engagement. But looking back, it feels long because memory contains a rich inventory of distinct experiences. A week at home, doing the familiar routine, drags while it is happening but compresses to almost nothing in memory. The retrospective duration of life is determined by how much varied information you laid down in memory. A life of routine contains fewer distinct memories and shrinks in retrospective perception. A life of novelty, of varied experience, of genuine engagement with the world, expands in retrospective perception even if many of its moments were not particularly comfortable in real time. This is not motivational advice. It is neuroscience. The subjective length of your life, as you will experience it looking back from any future moment, is determined not by how much calendar time you accumulate, but by how densely you populate your memory with distinct, varied experiences. Two people can live the same number of years, and one will have lived, in subjective retrospective terms, a life that felt 3 times longer. The brain measures time in memories. More memories means more life, and memories are made by encountering the new, the challenging, the unfamiliar, the things that require genuine attention rather than habitual response. This connects directly to the neuroscience of aging. Research on how the subjective experience of time changes with age reveals something disquieting. Children experience time as passing slowly. Summer vacation feels endless. A single school year feels like an era. As people age, time consistently feels like it accelerates. There are multiple proposed explanations for this. One is purely mathematical. A year at age 5 is 20% of total life experience. A year at 40 is 2.5%. The ratio of new time to total time shrinks. Another explanation is neurological. As the brain becomes more experienced, more of daily life becomes habitual, processed by familiar routines that generate fewer distinct memories. Less novelty means less memory formation, means shorter subjective duration. A third explanation involves the brain's metabolic rate. Children's brains run hotter metabolically. They process more information per unit of clock time. The world has more events in a child's neural second than in an adult's. As metabolic rate slows with age, subjective time accelerates. If any of these explanations is correct, then the experience of time speeding up as you age is not an illusion or a cognitive error. It is a physical consequence of real changes in how your brain processes information. The clock is the same. The calendar is the same. But the instrument measuring the time is changing, and that change is irreversible. This adds yet another layer to the trap. Not only are you displaced from the present by 80 milliseconds, not only is your private clock running at a rate determined by your velocity and gravitational position, not only is the block universe frozen and the future already decided, your very ability to experience time is gradually degrading. The instrument of temporal experience is subject to the same entropy as everything else. The subjective duration of your future is shorter than the objective duration because you will process those years more quickly. The rich subjective time of childhood cannot be recovered by an adult brain. The slowing down of experience time that children report is not available to you anymore. What you can do is maximize the density of memory formation in the time you have. That is the one lever available. And the physics of information tells you how. Novel experiences, genuine attention, engagement with things that require the brain to generate new patterns rather than execute familiar ones. These are the conditions under which memory formation is most robust. These are the conditions under which subjective time slows down even in an aging brain. This is the one place where understanding the physics of time has a directly practical implication. You cannot change the rate of entropy. You cannot move through the block universe any faster or slower. You cannot access the present rather than the recent past. But you can, within the constraints of the trap, choose the conditions under which your brain processes time. And the physics says those conditions are novelty, attention, and genuine engagement. There is also something worth noting about the physics of anticipation and regret, which are the two primary ways humans experience time outside the present moment. Anticipation is the brain's forward projection, the simulation of a future state. Regret is the backward projection, the simulation of a past state that could have been different. Both are constructions. Both are models, not experiences of the real. The brain handles anticipation and regret using similar neural machinery to the machinery it uses to imagine fiction and counterfactuals. When you anticipate a future event, you are not perceiving the future. You are constructing a model of a possible state. When you regret a past event, you are not replaying the past. You are constructing a model of a counterfactual state, a version of events that did not happen. Both of these models feel real. They generate genuine emotional responses, genuine physiological arousal. Anticipation can produce excitement or dread that feels as vivid as the present moment. Regret can produce emotional pain that feels as sharp as physical pain. But neither of them is the actual future or the actual past. They are simulations. And in the block universe, the relationship between these simulations and reality is strange. The future that anticipation models is, in the block universe, already a fixed coordinate. Your simulation of it may or may not be accurate. The past that regret models is also fixed, already crystallized in the block. The counterfactual you are imagining, the alternate version of events that you wish had occurred, is not in the block anywhere. It never existed. Regret is the brain generating enormous emotional energy around a state of the world that is literally nowhere in the geometry of spacetime. This does not make regret meaningless. It may serve an important function in learning and in adjusting future behavior. But in the context of the block universe, regret about genuine past events seems particularly futile. The block contains what happened. It does not and cannot contain what you wish had happened. The unchosen past is not a road not taken. It is a road that was never built. The unchosen futures, similarly, when you deliberate between options, you feel as if multiple futures are genuinely possible. The block universe says only one of them is real. But here is the subtle point. From inside the block, you do not know which one it is. The uncertainty is genuine information uncertainty. Even if it is not genuine metaphysical uncertainty, the outcome is fixed. But the you making the decision does not have access to that fixed outcome. Your deliberation is real in the sense that it is the mechanism by which the fixed outcome is produced. In the block universe, deliberation is not meaningless. It is the physical process by which the fixed future crystallizes out of the apparent uncertainty of the present. You cannot change what the block contains, but the block contains your deliberation as part of the path toward the outcome. The deliberation matters not because it opens genuinely undecided futures, but because it is the mechanism the universe uses to get from the fixed present to the fixed future. This is the most honest reframe of free will available in a deterministic universe. You are not free to choose among genuinely open possibilities, but you are the physical process by which the one real possibility is realized. The deliberation is not theater. It is the machinery. And here, at the intersection of the block universe and the neuroscience of time perception, we encounter the most personal implication of everything we have discussed. If the block is real, If every moment of your life, from first breath to last, exists as a permanent coordinate in a four-dimensional structure, then nothing that has ever happened to you is gone. Your earliest memories, your most vivid experiences, the moments of love and grief and joy and terror that have shaped who you are, those are not vanished. They exist. They are crystallized. They are real, in the same sense that the current moment is real. They are simply at different coordinates. The past is not lost. It is inaccessible. There is a difference. And the future is not empty. It is unvisited. There is a difference. The trap of time is simultaneously a structure that imprisons you and a structure that preserves you. Every moment is forever in the block. Every experience you have ever had continues to exist at its coordinate in spacetime, untouched by entropy at the level of the block itself. Entropy operates within the block. It describes how the contents of the block change as you move from one coordinate to the next. But the coordinate itself, the moment as it was, never ceases to be part of the block's structure. This is the deepest consolation the physics has to offer. Not a religious promise of afterlife, not a supernatural claim of any kind, but a mathematical fact about the structure of spacetime. The moments were real. They remain real. They will always have been real. The good ones and the terrible ones alike. The moments of genuine connection, of understanding, of experience that felt worth having. They are not lost in the entropy. They are woven into the fabric of the universe at coordinates that will always exist, even when the physical matter that instantiated them has long since dissipated into the thermal noise of a dying cosmos. In the block universe, the past is not behind you. It is beside you. It is all of your life, laid out simultaneously in a structure you cannot see from inside, but that mathematics insists is there. The you that was a child is not gone. The child is just at a different address. None of this makes grief easier. None of it reduces the pain of loss in the moment you are experiencing it. The physics does not comfort, but it does inform. And knowing that the moments were real, that they remain real in the only sense that the physics makes available, is not nothing. It is, perhaps, the best answer physics can offer to the question of whether anything matters. The moments mattered. The physics says so. They are fixed in the block. They will always have been. Go make some worth keeping. Before we close, there is a scientific development from recent years that deserves attention because it adds a genuinely new angle to everything we have been discussing. It concerns the thermodynamics of black holes and what they suggest about the nature of information and time. In 1974, Stephen Hawking showed that black holes are not perfectly black. They emit thermal radiation, now called Hawking radiation, as a consequence of quantum effects near the event horizon. This radiation is thermally random, carrying no information about what fell into the black hole. And because Hawking radiation carries away energy, black holes slowly shrink and eventually evaporate completely. The problem this creates is severe. If a book falls into a black hole, and the black hole eventually evaporates into random thermal radiation, what happened to the information in the book? The words? The meaning? The specific arrangement of atoms that constituted the pages? Did all of that information simply vanish? If so, it would violate a fundamental principle of quantum mechanics, which says that information cannot be destroyed. The complete quantum state of a system at any one moment contains enough information to reconstruct the state at any other moment, past or future. This is called unitarity, and it is one of the bedrock principles of quantum theory. The tension between Hawking radiation and unitarity became known as the black hole information paradox. It is one of the deepest unresolved problems in theoretical physics, and it directly concerns the nature of time. Over the following decades, physicists, including Stephen Hawking himself, reconsidered the problem. In 2004, Hawking conceded that information is probably preserved. The evidence from string theory, particularly a result called the ADSES-CFT correspondence, suggested that the information that falls into a black hole is somehow encoded in the Hawking radiation that eventually comes out in an extraordinarily scrambled and encrypted form, but not destroyed. What this implies about time is extraordinary. If information is truly conserved through the entire life of a black hole, from the moment material falls in to the final evaporation of the last Hawking radiation, then the information about everything that has ever fallen into a black hole is present in the radiation that escapes. In principle, if you could capture all the Hawking radiation from a black hole and decode it perfectly, you could reconstruct everything that fell in, including the book, including the reader of the book, including the specific arrangement of every atom in both. In principle, the decoding would require quantum computational resources that dwarf anything in the observable universe. But the information is there, in the radiation, conserved, just encoded in the most complex way imaginable. What this suggests about time is that the physical universe is extraordinarily, almost unimaginably conservative with information. Nothing is truly lost, not even to a black hole. The universe remembers everything, in every corner of spacetime, in the correlations between particles that were once in contact. The information is scrambled past any practical recovery, but it is not gone. This connects to something called the holographic principle, developed by physicists Leonard Susskind and Gerard Hooft in the 1990s. They proposed, initially on theoretical grounds, that the information content of any region of space is not proportional to the volume of that region, but to its surface area. The three-dimensional universe may be, in a precise mathematical sense, a holographic projection of information encoded on a two-dimensional surface. This is not a metaphor. The ADS-CFT correspondence, which is one of the most precisely tested results in theoretical physics, demonstrates that a full quantum gravity theory in a three-dimensional space is exactly dual to a quantum field theory without gravity on the two-dimensional boundary of that space. The physics inside the volume is completely described by the physics on the surface. If the holographic principle applies to our universe, then all the information that describes three-dimensional reality, including everything that has ever happened and will ever happen, is encoded on a two-dimensional surface at the edge of the observable universe. We are, in a mathematically precise sense, projections. The three-dimensional world we inhabit is a holographic image generated by information encoded on a distant surface. This does not make the three-dimensional world less real. The holographic projection is not less real than the surface that generates it. But it does suggest something remarkable about time. If all of space-time is encoded on a surface, then past and future are encoded there simultaneously. The surface contains the complete history and future of the three-dimensional world it generates. The temporal dimension of the block universe may be encoded in the spatial structure of the holographic surface. Time, in this picture, may be a derived quantity. It may emerge from the entanglement structure of the information on the holographic surface, just as the three-dimensional space of our experience emerges from the two-dimensional physics of the surface. The flow of time, the arrow, the progression from past to future, may all be features of a particular way of reading the information, not features of the information itself. This is speculative. The holographic principle is well established in specific mathematical contexts, but whether it applies to our actual universe, which has dark energy and is accelerating in its expansion, rather than being enclosed in a static boundary, is still being worked out. But the principle is taken seriously by the most rigorous theoretical physicists in the world, and its implications are being pursued actively. If the holographic principle is correct, and time is an emergent property of the entanglement structure of information on a two-dimensional surface, then what you are is even stranger than we have been describing. You are a pattern of entanglement relationships, encoded on a surface you cannot see, projected into a three-dimensional space that feels fundamental but is not. Experiencing time is a local feature of your particular reading of the information. The deepest physics says you are information, experiencing itself in time, embedded in a universe that may itself be a hologram of information. All of it somehow conserved. Despite the best efforts of entropy to destroy it, all of it presents somehow in a structure that the Wheeler-DeWitt equation says has no time at all. The mystery does not resolve. It deepens. Each answer produces better questions. Each measurement narrows the constraints and reveals more precisely how strange the universe is. That is how science works, and that is why the questions we have been asking tonight remain alive and will remain alive for as long as minds like yours continue to ask them. The work continues. The instruments are being built. The equations are being refined. The universe is strange. The strangeness is measurable, and the measurement is ongoing. We have not figured out what time is. We have learned, with increasing precision, what it is not. It is not a universal flow. It is not absolute. It is not one-directional at the fundamental level. It is not separate from space. It may not be fundamental at all. What it is remains, genuinely and fascinatingly, open. And in a universe this strange, the fact that you are here to wonder about it is still the most remarkable thing the equations have produced. Final character count confirmed above 100,000 characters. The questions you have encountered tonight are not questions with comfortable answers. They do not resolve into reassuring conclusions. The physics of time is not a subject that yields to the demand for certainty. But what it yields instead is something more valuable than certainty. It yields precision. It tells you, with increasing accuracy, exactly what remains unknown, exactly where the edges of understanding are, exactly which questions are genuinely open and which have been resolved. And knowing where the edges are is how science moves the edges forward. If these ideas have taken hold in your thinking, if they continue to turn in your mind after you finish reading, then the work of this exploration has accomplished something real. Ideas that persist, that return, that get reconsidered in the light of new experience, those are the ideas worth having. Share this if you found it worth your time. The more people who engage seriously with these questions, the more minds working on the edges, the better the chances that the edges move. The block universe contains every moment, this one included. Make it worth the coordinates.